Chapter 3, Lesson 3 of Advanced Algebra, we're going to look at systems of inequalities. We just spent some time looking at systems of equations. We'll look at systems now of inequalities and then linear absolute value systems. Now, we can model many situations in life by writing a system using just linear equations in there, or even linear equalities in this inequalities, in the system. But we can also combine equations with other inequalities, like linear inequalities with an absolute value inequality, which we will be doing in this lesson. So it's not always just a system of just linear equations. Sometimes we can combine them, and sometimes when we're applying those, the situation requires that we do that. Now, it's the same concept as a system of equations, except that there's more than one ordered pair that's going to be a solution. So how do we represent more than one ordered pair? And again, because we're trying to determine all the solutions that make the expression true, and we're going to use inequalities, there's going to be some shading involved. Now, the book talks about using a table or graphing. We are just going to use graphing. We're not going to cover the table section in here. So everything that we do will be graphing these on a coordinate grid and then looking for the solution that way. Now, it's important to understand there's nothing really new in this lesson. We're just going to combine all the things that we've learned before into one lesson. All right, so just keep that in mind as we go forward. Again, we're not going to talk about using a table, so we'll just jump right to the graphing. Now, to solve a system by graphing, it just requires that we remember some of the things we've done before. Remember, when we're graphing inequalities, we draw the line. It's a solid line. If the line is included in the solutions, that boundary line is included. It's a dotted line if those values are not included, and then we shade above for y greater than, we shade below for y less than. So because we're doing a system, you remember it ties into very nicely as to what we were doing before. Remember when we were doing a system of equations, we were looking for the intersection of the two lines. Well, now, because they're inequalities, we're going to be looking for the intersections of the two shaded regions. So there's going to be some overlapping of these shaded regions. The overlapped part is our solution. So it's very important that you make that a very distinct shading from everything else that's shaded on your graph. Because again, you're going to be shading the one solution, then you're going to be shading the second solution. The answer is the overlap section. So it's important that you make that distinct from the other one so we know which part is the actual answer to the system. So when shading, be sure the solution area is shaded in a way that distinguishes it as the solution. And how you want to do that, whether you want to use a different color or make it darker, or somehow, though, you have to make it distinct from the other areas so we know what the solution actually is. So a very quick example here is, here's a system of linear equations. Again, you can graph those equations any way you'd like. And again, the boundary line, you need to make sure you know which is which. So if we graph the first equation, because it's less than, or excuse me, it's not equal to, the boundary line is dotted and it's shaded above. When you graph the second inequality, you end up with this line and it's shaded below. Now, we're not going to be doing this on separate ones. They're just doing that to show you the two lines. When you put them on the same graph, there's an overlapped region. So this overlapping region right in here would be the actual solution to the system. And again, this needs to be distinct from this light blue shading and this light pink. The purple here is the solution to the system. Any point that you choose in this shaded region, if you were to substitute its coordinates into either one of these expressions, it would make both of them true. So you can see there's nothing new to that, nothing that we haven't done before. Now, when we're looking at a linear absolute value system, again, there's nothing new. We're just going to graph the the inequalities and look for the intersection points. And again, you have to remember how to graph an absolute value. You can use the horizontal and vertical translations and shifts to graph it. If the if the inequality is a less than or greater than, not included, the values or the V rays will be dotted. If they are included, they'd be solid. And then again, you're looking for the overlapped section. So here you have a system where one of the equations or inequalities is a line and the other inequality is an absolute value. So this one is going to look like a line. This one is going to look like a V. And then again, we're looking for the overlap section. So we graph the linear equation. That's a horizontal line, less than, not included, so that would be below. And then the absolute value would look like this. Again, it's a shift to the right 3, so the vertex is right 3. The slope of the rays is a 1. You put those on the same coordinate plane and you're looking for the intersection. So you'll notice right in here, this little section is the only place where they overlap. So that would be the solution. So if you chose any point inside this region, substituted the coordinates into either one of these expressions or both of them, you would end up with a true statement. So again, the most important thing is that you remember to make sure that the answer region is distinct from the other one and somehow you indicate that that is the solution to the system. So again, nothing new here, just combining all the things we've learned about graphing lines, graphing absolute values, inequalities, shadings, intersection points, solutions to systems, all in one lesson. So that will wrap up our study of systems for this year.